In this video we will look into sales mix calculations as part of product management concepts, and understand how break-even point is estimated for each product, when a product is part of a product mix using the sales mix data. Sales mix is the relative percentage or proportion or ratio in which a company sells its products. For example, if a company's unit sales are 80% printers and 20% computers, then its sales mix is 80% is to 20%, or a ratio of 4:1. Sales mix is important because different products often have different contributions to total sales, and hence each product's contribution to total sales needs to be understood to understand which products are more important. We did a similar exercise in our ABC analysis video. In order to perform a calculation, let's take a situation where company A, B, C sells 1,500 units of printer and 500 units of computer. We need to determine the sales mix. From the data we see that total sales is 2,000 units. Thus, sales mix consists of contribution from printer and computers. Contribution of printer is 1,500 multiplied by 100 and divided by 2,000. That is 75%. Whereas, contribution of printer is 500 multiplied by 100 and divided by 2,000. That is 25%. Thus, the sales mix consists of 75% printer and 25% computer. Break-even point in sales is that unit in which the company neither makes a profit nor a loss. Determining break-even point based on units sold for a single product is easier and can be done with the formula as shown here. Break-even point is equal to total fixed cost divided by the contribution margin, where the contribution margin is the selling price per unit minus the variable cost per unit. Let's take an example to understand this. Say for example a company A, B, C sells printer at the rate of Rs 1,000 per unit with a variable cost of Rs 500 per unit and total fixed cost of Rs 100,000. The contribution margin is thus 1,000 minus 500, that is Rs 500 per unit. So, the break-even point is 100,000 divided by contribution margin, which is 500. This given break-even point is 200 units. So, in selling 200 units, the company makes neither profit nor loss. Just to understand the break-even point better, let's take two scenarios, one with units sold as 210 and another with units sold as 190. We want to check what happens when the company sells less or more than the break-even point. We see from the table 1. When the unit sold is 210. The total variable cost is 210 multiplied by 500, which is the variable cost per unit. This gives total variable cost as 105,000. When we add the total fixed cost of 100,000 to it, we get the total cost is 205,000. Similarly, selling price per unit is 1,000, and company is selling 210 units. So the total sales revenue is 1,000 multiplied by 210. That is 210,000. So, profit, which is basically sales revenue minus total cost, results in a profit of 5,000. Whereas in table 2, when the unit sold is 190, and with all other cost combinations, the total cost is calculated as 195,000. The total sales revenue comes out as 190,000, which results in a loss of 5,000. Thus, we see that selling any unit above the break-even unit will lead to profit, and any unit less than break-even unit will result in a loss. But when the product is part of a product mix, then we cannot perform the break-even analysis on an individual basis. This is because the fixed cost may be shared by all the product in the product mix. Thus, in such case we compute weighted average unit contribution margin of all the product. Let us consider an example to understand this better. Say the company ABC has the following product-related details as part of its product mix. The company is selling 1,500 units of printer and 500 units of computer. The selling price of 1 unit of printer is 500 and 1 unit of computer is 1,000. The variable cost for printer is 200 per unit and for computer it is 500 per unit. The fixed cost is 300,000. Let's look at how we determine the weighted contribution margin. We can calculate the contribution margin for each product by subtracting variable cost per unit from selling price per unit. For printer it would be 500 minus 200, that is 300 as the contribution margin. For computer it would be 1000 minus 500, that is 500 as the contribution margin. We also need to determine the sale mix, as we demonstrated earlier. Thus contribution of printer to total sales is 1,500 multiplied by 100 and divided by total sales, which is 2,000 units. Thus the contribution of printer is 75% to total sales. Similarly, contribution of computer is 25% to total sales. Thus sales mix for the company is 75% printer and 25% computer. As a first step, we determine the weighted average contribution margin. Weighted average contribution margin is unit contribution margin of printer multiplied by sales mix percentage of printer, plus unit contribution margin of computer multiplied by sales mix percentage of computer. For this case it is equal to 300 multiplied by 75%, plus 500 multiplied by 25%. This results in 275. In step 2, we use the weighted average contribution margin calculated earlier to compute the break-even point in units. Break-even point in units is equal to fixed cost divided by the weighted average contribution margin. That is, 300,000 divided by 275. This gives us 1090.91 units, or approximately 1091 units. In step 3, we use the sales mix to determine the break-even point of the individual products. The break-even point for printer is equal to 75% of total break-even points, that is 1091 units. Which gives us 818 units. For computer it is 272 units. Thus, we observe that in case of single break-even point can be calculated by dividing the fixed cost by contribution margin. Whereas in case multiple products in product mix, we can calculate the break-even units by dividing the fixed cost by the weighted average contribution margin. And the individual product's break-even point can then be calculated by multiplying the sale mix percentage or contribution percentage with the break-even point as calculated above. Thank you.